Hello everyone, today we're going to be looking at everyday electrical appliances. So last week we looked at how electricity is generated, which I hope you enjoyed. Certainly was interesting to see the work that you produced. You did such an amazing job. You should be really proud of yourselves. So I'm going to look at what is an appliance today. And although we're, mainly focusing on electrical appliances, we're going to be looking at different types of electricity that our appliances run from. So, without further ado, what is an appliance? So basically, an appliance is something, either a device or a piece of equipment, or an instrument that does a task, that does a job. So here on the screen we've got the example of a washing machine. It's an appliance that performs the task of washing your clothes. Can you think of another appliance in your home? Shout it out now. So like me, you probably jumped, maybe if you have a dishwasher, to the dishwasher or the oven. It tends to be quite easy to think about the kitchen. But also, I was thinking about things like maybe you might have an Alexa at home or a DVD player. These are all appliances. They're all something that does a job. But the ones I've talked about so far pretty much have all used electricity. And on the right, you'll notice that we've got a thermometer. Now, this is an old-fashioned style thermometer. It's not a modern thermometer that has a screen that tells us what the temperature is. This one has a liquid in it. Now, the liquid that used to be in them was a liquid called mercury, which is actually poisonous. But most modern thermometers contain a different liquid. And what this liquid does is it expands when the temperature gets warmer. Now, from your spellings, you should know that expands means that it gets bigger. So the greater the temperature, the bigger the liquid inside the thermometer gets. So it helps us to measure the temperature. So a thermometer is an appliance because it performs the task of allowing us to check the temperature. So here we've got some more electrical appliances that you might have thought about. We've got everything from mobile phones to lawnmowers to toasters to a tablet. And then it's the non-electrical appliances that made me think, some of these, they are an appliance, they do a job. A saucepan does do a job, that's otherwise known as a pan, for those of you who hadn't worked out what one was. They all do a job, but they don't rely on electricity to do it. Some of you, though, might have some of those non-electrical appliances. You might have an electrical version. For example, a coffee grinder. You can get ones that are electric. Ovens, you can get ones that are electric. Toothbrushes, even potato peelers, you can get electric ones. And pencil sharpeners, although it's just pencil, not pencil sharpener, but never mind. But lots of those you can get electrical ones as well. But so we've got electrical appliances and non-electrical appliances. Now, in terms of the types of electricity, in the UK we use two types of electricity. We have mains electricity, which is devices that we need to plug into a plug socket that connect to the national grid, connects to all the pylons and everything that you can see around, and gets power from the power station or from turbines and those sorts of things. So these use electricity, and you need to plug the appliance into a socket, as it says. The other type of electricity that we use is battery electricity. So this is energy which is stored inside the battery battery or cell, and that energy is then used to power the device. So here on the picture example, we've got a mobile phone that uses a battery in order for it to work. Can you think of something else that uses a battery in order for it to work? I'm sure a list of things are coming into your mind right now. So, let's now look back at mains electricity. So, in the UK, mains electricity is produced in a number of ways, and there are different power stations that produce energy in different ways. So, we've got gas, coal, or nuclear power stations. So, in terms of gas and coal, what they do is they burn the gas or burn the coal, and that produces heat. And what they then do is that heat is used to heat up water, which then produces steam. And that steam turns a turbine, and the turning of the turbine produces electricity. Now, it isn't actually just gas and coal that they burn. Increasingly, power stations are starting to burn biomass. And biomass is basically something that grows, usually plants, things like wood and that sort of thing. They burn instead of gas and coal because it's a little bit better for the environment. And the other example we've got there is nuclear power, which is some very clever science. Which also, again, the nuclear power is used to heat water, which then turns a turbine, which makes the electricity. Now, in the modern world that we live, we are really concerned about the amount of things that we are burning and the amount of fossil fuels that we are burning and the damage that's doing to our planet. So other ways of generating electricity these days are things like wind turbines, where instead of something burning and creating steam to turn the turbines, that the actual wind itself that we have all around us most of the time turns the turbines to make the electricity. We have solar panels, which take the energy from the sunlight and turn it into energy that we can use. We also have hydroelectric power, which is using the power of water in order to make electricity. So the water flows, and as the water flows, it turns a turbine, which in the same way as the other power stations that we've talked about, that turning of the turbine makes electricity. But these types of electricity, maybe we don't generate as much electricity this way in the UK. And some people's homes might even have solar panels on the roof, either to create electricity or to warm water, either one or the other. So, we know that power stations generate electricity, and they generate electricity all the time, which is useful to us because if you think about a wind turbine, if it's not windy, it doesn't generate as much electricity. Or if you think about solar power during the night when it's dark, they're not generating electricity. So power stations are a constant way of generating electricity. So we've got our power station, an electric current is generated and then sent through wires to a transformer. The transformer, that's where the current is sent along the wires that are attached to pylons to cities, towns and villages. So here we've got our pylons that connect the first transformer to the transformers near cities. So transformers are really important because they keep the current and of the electricity, they keep the electricity strong in a sense, so that we can use it. The second transformer connects to the wires from the pylons, and in most cases these wires are then placed underground because we don't have electricity cables travelling through the air to our homes. They tend to be underground to our homes. So the underground wires connect the transformer to buildings, including homes. And once in your home, the wires then distribute the electricity through your house, and you don't see them because the wires are inside the walls. The only time when you do see these wires in some way is you see the socket that's attached to the wires, which is on your walls in your house. And here we've got some different types of batteries that we might be familiar with. They've got chemicals in them which produce an electric current. Eventually those chemicals get used up and they stop working as they can't produce any more electrical current. So we've got some standard batteries that you might recognise, and we've also got a car battery there, because cars need batteries as well for all the electrical components. Because although cars use petrol in order for them to work, on most cars do these days, they do need electricity to actually start the car. So it's really important that the battery in the car works. Otherwise the starter motor won't work, so the car won't be able to start. What we also have, when we come to talking about batteries, is we have rechargeable batteries. So this is where we plug the batteries in, and the chemical reaction that takes place in the batteries that makes and stores the electricity is reversed. So by plugging it in, it reverses the chemical reaction, and those batteries can be used again. So, electricity is a wonderful thing. It's really good how it travels to our homes, how it's produced, how we have, electrical appliances that use mains power, electrical appliances that use battery power. But electricity is also pretty dangerous. It's actually something that can really hurt you. It can also kill you if you are not careful. You can get a minor shock to quite serious and nasty burns. So it's really important that we look at staying safe. So I'm going to show you a website, and this is going to be our first activity. Is to go onto this website, go into the different rooms, and what you've got to do is it gives you some electrical advice. Some of it seems quite silly and quite obvious. So I'm going to show you one room, and I want you to then explore the other rooms in order that you can maybe make a list of some key pieces of advice, because you are going to need these pieces of advice for your activity for this week. So I'm going to press on the house, and that should take me onto the internet, onto the website that you're going to be using today, called Switched On Kids. Now I'm going to start with the bedroom. So in we go. Yeah, my hair's looking quite like that at the moment, to be honest. It's getting quite long and a bit spiky here and there because I can't put gel in it. So yeah, he does look a little bit like me at the moment, although I'm not quite sure I'd wear that colour of trousers. So what we've got to do is we've got to go around the room, and we've got to find things. There's 7 dangers in this room to do with electricity. They tend to be quite easy to find because they do wobble a little bit. So if you look at the screen quite carefully, you can probably spot some things wobbling. The first thing that's wobbling to me is the light above his head. So let's have a press on that.
Always get a grown up to change light bulbs.
Which is a really important thing, obviously, to get grown-ups to do. If your light bulb stops working, ask an adult to change it for you, because they know what to do to make the electricity safe in order to change the light bulb. So that's our first one. So we've done that one, so that's 1 found. And I'm looking for something else that's wobbling. Here I can see a lamp.
Always get a grown up to change light bulbs.
Okay, same as the one we've already done. I've got this here. I've got this keyboard that's wobbling around, so let's have a look at that.
Don't let leads from electrical items trail across the floor.
That's that one. That CD player keeps moving.
Never leave electrical things on when you're not using them.
I think it's important that the second bit are when you go to bed. Okay, I can't help but notice the drink on top of the TV.
Always keep drinks away from electrical things.
You can get an electric shock because water and liquids that contain water are really good conductors of electricity. So therefore, water and electricity don't mix, so keep drinks away from electrical appliances, which is why I always go, not mad, but I always point it out whenever we go into the ICT suite that you should not be keeping your water bottles near the computers. And actually, when we go to the ICT suite, you shouldn't take your water bottle with you anyway. So that's that one. TV. Oh, it's just turned off.
Danger. Never stick anything into the holes of a socket.
Okay, that's that one. I've got one left, which I think is the other plug socket, which perhaps tells me the same
Danger.
thing.
Never stick anything into the holes of a socket.
There we go. And then to get back to the house to go to look at a different room, I just press on back to start, and it takes me back to the home page. It's just been a little bit slow. However, I'm going to take you back to the PowerPoint, which I'm hoping is going to work, to introduce your task to you this week. So this week, I would like you to produce an electrical safety poster. Here we've got some different posters. They're not about electrical safety. We've got a fireworks safety, we've got a safer internet poster there, we've got a one about, I think it's about germs. What I want you to do is to produce a poster that encourages people to be safe around electricity. So when you've been around the other rooms of the house, hopefully that will perhaps have given you a list of things that you can use to make an electrical safety poster. And that's all from me for today, so keep safe and keep washing those hands.